Hello, ladies and gentlemen. Welcome. We're going to be talking today about skill 8.4, which is scale factor. So scale factor, kind of an example is, let's say that I buy Alice a toy from Kentucky Horse Park, and maybe in the box it stands 6 inches tall. And it says on the box that it has a scale factor of 1 to 12. So what this means is that on the bigger real life, I would just take the 6 and multiply it by 12, so its actual size would be 72 inches. So scale factor just indicates what we have to multiply or divide by to get that segment length in the enlarged or the reduced size figure. So scale factor is the number by which all the components of the object are multiplied to create a proportional enlargement or reduction. So here's what I mean by this. So let's say that I'm going from the small to the big. So this is like the old, and this is the new. So if I did 5 times 2 to get me 10, on this one I would do 3 times 2 to get me 6. And I would do 6 times 2 to get me 12. So I'm just multiplying by the same thing. And if I were to go the other way, I would just multiply by 1/2 each time. The order does matter. So if you are getting bigger, your scale factor is going to be larger than 1. And then if you're getting smaller, your scale factor is going to be smaller than 1. So I like to think about this as doing the new over the old measurement. And we're actually going to look at some Delta math examples and just go right in. So I'm going to kind of assign you scale factor problems of different levels. And then also scale factors with areas is kind of a more enrichment level type of problem today. So please follow along and look at the examples that we do. All right. The first type of problem is just find the scale factor. So what this is saying is the right triangle on the right is a scaled copy of the right triangle on the left. So we are going from this triangle to that triangle. So new, and this one is the old. So we're going to do new over old. And it says identify the scale factor. Express your answer as a whole number of fraction or a fraction of simplest form. And you can see that these sides, it's kind of rotated, but the 20 and the 5 match up. So I'm going to do 20 divided by 5. So we can actually say that the sides are 4 times as big in the new triangle. So I'm just going to put that as 4. Let's look at another problem here. It says scaled copy, identify the scale factor. Now this one, maybe somebody who's pretty quick may make the keen observation and say, oh, what do I need to multiply? And we may actually kind of observe that the sides of the new triangle are twice as big as the sides of the old triangle. So if you kind of thought about it that way and it was readily available for you to see. This is actually another way that you could kind of think about it. So it would just be 2. And let's do something a little bit more fractional when we are going smaller. So this says that the rectangle of the right is a scaled copy of the rectangle on the left. So I like to label my new and old. So this is new. This is old. Now notice the 4 is the shorter of the two sides and the 12 is the shorter of the two sides. So I look at what matches. So I have new over old and I get 4 over 12. Now that's not a simplified fraction, so I want to make sure that that is a completely simplified fraction. So I get 1/3 in total. And then you just enter it. You do 1/3. And that will get you a good scale factor. Now let's actually take a look at level 2s. This is express your answer as simplest form. Scaled copy. So new is always on the right, old is on the left. And on this one, I would get 49 over 10. And it says express your answer in simplest form. I could actually try and see if it would accept decimal. This would be like 4.9. And it actually is simplest form, so a decimal is fine. So that's what kind of makes it like level 2, to be honest with you. We also have the areas. This is rectangles H and J are similar. What is the area of rectangle J? So this one's going to take a little bit more thinking on your part. So the first thing I would do is I would find out what the length is of this rectangle. There's actually multiple ways that you could do this problem, but to kind of simplify things, we'll just kind of do the length. So the area is length times width of a rectangle. So length times width equals to 266. My width is 19. So when I do 266 divided by 19. So I get 14. And then on this one, I'm kind of thinking about, so it says that they're similar. So I'm going to want to find what this side length is. So maybe I would do 9.5 over 19. That's new over old. Well, J over H, I could say. And that would be equal to X over 14. You want to cross multiply. So I got, for this one, 14 times 9.5. That's 133. Equals to 19x. Divide both sides by 19. And I get that x is equal to 7. So rectangle J would be 7 times 9.5. So my area would be 66.5. Now another way to do this. So if I have 9.5 out of 19, that's a half. So another way that you could do this is you could do 266 times 0.5 times 0.5 again. And the reason is because we're doing the scale factor in both directions. And I can kind of see here that the scale factor is 9.5 over 19. So it's a half. So if I'm doing it in both directions for the area, I get 66.5 as well. So you multiply by the scale factor twice when you do area. So actually, what you can see here, they kind of did the way to route. If you look at the answer, they computed the scale factor first, and then they did the area scale factor, which is taking the scale factor twice. And that way you didn't have to do all that crazy work. So let's kind of do the area approach on this one. So on this one, I would compute the scale factor. So that's just 2 over 8, which is 0.25. The area scale factor is just a scale factor twice. So it's 0.25 squared. So that's 0.0625. And then you could just do 48 times 0.0625. And you would get that your area is equal to 3. So I like the area problem because, you know, if you're taking like SAT or ACT, they may not just compute the basic scale factor. They may actually look into compute the entire, you know, area scale factor because it kind of extends it a little bit. So the area scale factor is just the scale factor squared. So thank you very much and have a great day.